Okay, welcome MAP4Cers. Day 67. This is lesson 7.2 on present value of annuities. Before we get into that, the goal of the 3-minute review is straight from yesterday's stuff, and we're also kind of, when we're learning how to do stuff with annuities, we're always thinking about making better decisions as far as these money is concerned here. So here's Ferd, and he's got two investment choices, and we want to know which one gives him the most interest. So if he's saving money, interest is good. If he's borrowing money, of course, interest is bad. System A, it's $600 every 6 months, so twice a year, $600. That's $1,200 a year at that interest rate. And notice that this is the same amount out of Ferd's pocket. $100 a month at 5% is still $1,200 a year. So these two investments out of pocket are the same. We want to figure out which is going to give him end up with more interest, more money in the bank at the end. And since we spent so much time last class working with the TVM solver, I'm going to use the formula for this example. We could use the graphing calculator, but we'll get to the graphing calculator again later. Okay, so what do we got? For the first one, A, the amount at the end is what we want to find, so we can find the interest. The regular payment is $600. The interest was 5% a year, but compounded semi-annually, so that's 0.025. N was 4 years, but twice a year, 8 payments, and I can bash that into a calculator, and I get Ferd will have how much at the end? 52.41 and 67 cents about. And then the interest, remember, I see interest is the total at the end, subtract what came out of his pocket, right? And he had 8 payments of $600, which is around $441 of interest. That's pretty good. Out of thin air, Ferd earns over $400 in interest. Good. System 2. Same formula. What changes? Not much. Actually, everything changes, doesn't it? The amount at the end we still don't know. The regular payment is $100. The interest rate is 5% monthly. Now, when I put this into a calculator, I get a big long string of decimals. It actually doesn't end and doesn't repeat. It's a mess. And so to be perfectly accurate, I'm just going to leave it like that and put it into my formula like that. And I would suggest that you do that. When you're dealing with people's money, Ferd's money here, you want to be as exact as you can. So I'm going to leave that, and we'll see that it's a little tougher to put in the calculator, but not so bad. N is 4 years and 12 payments, 48 payments altogether. And see, this is a little bit of a problem in here. It's a little bit of a mess in the formula, but we'll see that it's actually okay. And same thing on the bottom. When I'm dividing by I, I'm dividing by that expression rather than a number. So I'm going to put that in brackets, and we'll see how that changes our calculation. So go to my calculator. Where's my calculator? There's my calculator. And I'm going to start bashing away here. 100 times 2 brackets there. Bracket, bracket. Now I'm on this inside bracket. 1 plus 0.05 divided by 12, and then this inside end bracket to the exponent 48, subtract 1, end bracket, divided by, that's the long division bar, start bracket, 0.05 divided by 12, and I should get a number that's pretty close to this one, right? 5,200. So I get 53,0149. I can see that's a little bit more, but in the same ballpark. Interest is the amount at the end, subtract the payments. There's 48 payments of $100. Still the same $4,800 out of pocket, but this time Ferd makes a little over 500 bucks, doesn't he? So, what's the moral? It seems like the more frequent payments is more interest. And that makes sense. The interest is compounded more frequently, along with the payments being more frequent. All right. Dandy. And so let's get into today's stuff, whatever today's stuff might be. Solve problems involving the present value. We've heard those words before. Let's read the example. Grandpa and Grandma Ferd want to provide for Ferd's college experience, but don't trust they'll spend the money wisely. He will get $1,000 per quarter, so 4 times a year. Ferd's going to get a payment of $1,000 for 2.5 years for college. What amount should they have in the bank now to cover it? So the idea is Grandma and Grandpa Ferd want to put a pile of money in the bank and have this set up so that Ferd in college will withdraw $1,000, and then at the end of the 2.5 years, the account will be empty. What amount should they have in the bank now? Well, notice when I go to the graphing calculator, what I want to find, turn on the graphing calculator here and get the TVM solver warmed up. Come on now. Apps button, come on. All right. What's going on here? This stupid calculator. My calculator's broken. All right, well, let's exit it and turn it back on, see if it'll work. Get a fresh calculator going. There, okay, this looks better. This is more promising. TVM solver, dandy. So what do we got? Let's get rid of this. Every 3 months for 2.5 years. So that's 4 times a year times 2.5 years. 10 payments, that sounds fine. The interest rate was 6% monthly. The payment was going to be $1,000 that Ferd's going to take out. And it was 4 times a year. 4 times a year. And we want to know how much $1,000 Ferd's going to get, lucky Ferd. We want to know how much should be in the account now. So I'm going to solve for the present value. So it looks like about $9,000, which makes sense, right? There's going to be some interest that's growing on that $9,200 as it grows. 10 payments of $1,000 would be $10,000, but some of that's going to be interest that Ferd withdraws. So let me just put the note here. I'm going to copy into our notes. That was 10, and that was 6. This is what we solved for. It was 92, and that ended up being negative. 92.218. The payment was $1,000. Future value was 0. At the end, there was nothing left in the account, and this was 4 and 4 here. So note, we need to find the present value. Present value. And from the TVM solver, Grandma and Grandpa would need in the bank. No problem. And that's the amount that they'd need now, right? One thing that we might want to think about here, though, is okay, the calculator, that felt the same as the questions that we did before. How is this different than what we did yesterday? Well, think of this. This is the formula we know, right? Where's the present value in this formula? It's nowhere to be found. I can't solve for it. I don't know what the amount, well, the amount at the end was 0, wasn't it? The account was empty. Certainly this R would be 1,000, but there's no present value. You say, well, hang on, we know this formula, right? That's got a present value in it, except for there's no regular payment. It's kind of like these two formulas need to be combined, and they do get combined, and we get a brand new formula for these types of questions as the present value of an annuity, and we'll pick that up in part 2 of the video.